So I usually start my presentations the last few years with this slide. This slide basically shows the different crises that we are simultaneously facing, and it also shows the magnitude of the different crises. So it implicitly says that if we think that COVID was a huge catastrophe, then we might want to think about the other crises that are also presently at work, and also understand that the effects of these other crises, the recession that we derive from COVID, the climate crisis, the increased frequency and severity of extreme weather events, and the biodiversity collapse, the loss of the resilience of our ecosystem services, all this together with the population crisis, the increase in population and the very difficult distribution of this increase over the globe, make the status quo a very delicate situation. And basically they call for a simultaneous solution that will be holistic and integrated enough to be able to tackle all these problems together. So the world is only as resilient as the least resilient country and person, and we need to figure out the pathways, the technological pathways, the financial pathways, the socio-economic and policy pathways that will allow us to transition to a sustainable world that can heal all these crises, a world that will translate into the implementation of UN Agenda 2030, the implementation of the 17 Sustainable Development Goals, together with the Paris Climate Agreement, and if you are in Europe, together with the European Green Deal, which in principle we have worked on this, translates into the European transposition of the SDGs that can be integrated in existing and developing European policy framework. So I lead an alliance of excellence for research and innovation on Aiphoria. Aiphoria is a Greek origin word meaning sustainability. And we work on research and innovation on sustainability, trying to transform our research and innovation work into sustainability action. You can have a look at our website to see the different collaborating partners of this alliance. Very quickly, we have 3 research institutions: the Research Laboratory on Socio-Economic and Environmental Sustainability at the Athens University of Economics and Business, where my chair sits, the Sustainable Development Unit at the Athena Research and Innovation Center. This is the biggest research center in Greece on information technologies, and the private International Center of Research on the Environment, the Economy. I direct these 3 research centers. They work closely with each other, and they work on devising green and digital solution pathways towards sustainability. Then we have a cluster of innovation acceleration institutions, the Climate Kick Hub of Greece, which is part of EIT, the European Institute of Innovation and Technology, and focuses on accelerating innovations that are relevant to climate neutrality. We also have a Clim Accelerator, which focuses on accelerating innovation startups that are relevant for the transition of the maritime sector to a climate neutral and climate resilient sector. And we, at the moment, incubate 25 startups under this accelerator. And finally, Brigade Connect, which is another European accelerator, as is the Clim Accelerator, which at the moment incubates 120 startups that are relevant that provide solutions for climate adaptation, solutions for hedging against and managing floods, heat waves, extreme precipitation, forest fires, and so on. So these are our research and innovation institutions, and together with this, we contribute to various scientific associations and networks, the European Association of Environmental and Resource Economists, the biggest scientific association of environmental economists in the world, with members from 55 different countries, more than 1,000 members, and quite prestigious with regards to its footprint as far as research output is concerned. My mission as a president is to continue the research excellence, but also create the connection between environmental economists and technology developers. Technology developers need economics in order to identify solutions that are cost efficient, economically efficient, welfare increasing, correctly incentivized, and so on. But also increase the connection and the interface of environmental economies with the policy world. This is also important because economists have a lot to say about optimizing and developing efficient policies. There is a lot of intuition for ETS, for emission trading systems, for taxes, for valuing resources, for incorporating values into the decision-making processes and cost-benefit analysis and multi-criteria decision-making processes, but also a lot of input with regards to understanding consumer behavior and producer behavior, and trying to incorporate this understanding into the development of different frameworks that try to incentivize these behaviors towards sustainability action. One of the major platforms that we work with is the Sustainable Development Solutions Network, which is a global initiative for the United Nations. This is an initiative that has a hub in each and every country of the world. I coordinate the European hub. I co-chair the European hub with more than 400 university members, and also the Greek hub, which includes all the universities and research centers in the country. And the mission of the Sustainable Development Network is to bring the knowledge that it produces in research and innovation and institutions and universities, to bring this knowledge about sustainability, the solutions for sustainability, to the other stakeholders that need to work together in order to implement these solutions. So we are talking to politicians, policymakers, technology developers, businesses, financial institutions, NGOs, and the civil society. I'm also heavily involved in Water Europe, a big technology and innovation platform for water resources. I am co-chairing the water value section of Water Europe, and I'm also one of the founding members of Nexus Cluster, with more than 30 different European projects on water, food, energy, and ecosystems Nexus. So we work a lot in research and innovation projects, in innovation acceleration and deep demonstration, and education and training, and the science policy interface. At the moment, the Alliance has more than 200 researchers, and our 25-year competitive funding has reached more than 500 million. So there is a lot of work, and one of our most prestigious projects, as Ivana said, is the WaterFutures ERC, European Research Council, Synergy Grant, that tries to answer the question, how should the world achieve the provisioning of high quality water services in the future while facing severe climate, economic, and population pressures under deep uncertainty. Under uncertainty, which is not just a risk, it's uncertainty for which we don't know the probabilities. And it's a very a relevant project at the moment because SDG 6, SDG that has to do with water and sanitation, is one of the less well implemented SDGs across the world. This is our Sustainable Development Report produced by UN SDSN Network every year since 2015 when the Agenda 2030 was launched, and it shows the current implementation of the different SDGs. This is the SDG 6 implementation, clean water and sanitation, where you have green, you have the SDG achieved, yellow, challenges remain, orange, significant challenges remain, and red, major challenges remain. You can see that we are very far away from achieving full implementation of this SDG. And the bad news is that even by 2030, if we follow the current trends, we will still be far away from achieving this SDG. The picture is better than what we have today, but is definitely away from full implementation of this SDG in many countries of the world. And this project focuses on SDG on water and sanitation, but on urban water systems. Why urban water systems? Well, half of humanity, 3.5 billion people, lives in cities today, and 5 billion people are projected to live in cities by 2030. So by 2050, we project that 70% of world population will be living in urban settlements. And this shows how important it is to have an efficient design of water systems. Rapid urbanization is putting a lot of pressure on water supply, sewage, the living environment, and public health, and it needs to be designed in a welfare, increasing social cohesion, supporting economically efficient and environmentally resilient way. So these synergy grants have as 4 PIs. Myself, I am focusing on methodologies for analyzing rationality, ethical concerns, as well as uncertainty and ambiguity for decision and policy making, including lots of work on no-market valuation, virtual reality aided no-market valuation. Barbara is the other PI, Barbara Hammer, Professor Barbara Hammer from Bethel University in Germany, focusing on methodologies for explainable machine learning to explain changes in the system and the influence of certain parameters on long-term decision-making. Then Marios Polikarpou, Professor Marios Polikarpou from engineering department at the University of Cyprus, focuses on methodologies for real-time monitoring and control for explainable fault diagnosis and real-time risk assessment for both water quantity and quality. And Dragan, professor of hydrodynamics at Exeter University and also CEO of KWR in Netherlands, the biggest research institution in Netherlands that is funded by the different water utility. He's focusing on methodologies for water infrastructure planning and management, valuing robustness and flexibility under deep uncertainties. This is a 6-year, 10 million ERC synergy grant. Each one of us has 2.5 million to support a big team of researchers that works on the integration of these different issues. And we focus on long-run frameworks for drinking water network transitioning. We need the water network to be adaptive and flexible, robust under uncertainty and ambiguity. Real-time and long-term considerations need to be integrated into the same framework, and this is a big challenge. Water quantity and quality considerations, as well as economic, social, ethical, and environmental considerations. So we need to find a framework. We want to find a framework. We set ourselves this mission of finding a framework that can adapt to evolving urban water networks and new sensing technologies and changing consumer behaviors. A framework that integrates real-time monitoring and control with long-term planning and policymaking. A framework that assimilates water quality issues with water supply problems and incorporates economic, social, ethical, and environmental considerations. We set our first objective as developing a theory and application of this theory of robust and flexible decision support strategies to cope with deep uncertainty. We also want to develop new real-time distributed monitoring and evolving control methodologies, develop explainable machine learning models in non-stationary environments for complex structure and network data, to support human decision-making for smart water systems that are data-driven, develop a methodology that integrates economic, social, ethical, and environmental considerations that are relevant to Agenda 2030 and support societal welfare maximization, and also design and implement an open source tool that integrates the scientific outputs produced. And we're going to use water systems in the Netherlands, Cyprus, and Mexico in order to demonstrate our solution. With regards to the economics angle that I am managing in this project, we focus on trying to develop a unifying framework for real-time, short-run, medium-run, long-run decision-making under uncertainty and ambiguity. As we know, time and uncertainty are correlated. Uncertainty is time variant and often becomes ambiguity. We have two different approaches towards understanding this uncertainty. In economics, we have the discounted utility framework where decision makers select between alternative based on weighted sums of utility based on time preferences, and these are reflected into discount factors using the Ramsey rule. But we also have subjective expected utility where decision makers select between alternatives based on weighted sums of utility based on probabilities. And empirical evidence of ambiguity aversion in economics, which violates subjective expected utility axioms, is the beginning of our investigations. And our basic question is, do we need to train decision makers to be able to efficiently make decisions under ambiguity, or do we need to accept the fact that the subjective expected utility axioms are violated and maybe revisit those axioms when we are dealing with decision making under ambiguity? We are also touching upon issues that have to do with different attitudes or between people, people different with regards to how selfish and fair-minded they are. And this has important economic consequences. There are experimental evidence against the standard economic model of self-regarding preferences. So our ambition is to revisit decision theory and the axioms of the standard economic model in order to incorporate fairness and ethics. We also focus on deeper understanding of human preferences for public infrastructure and try to retrieve these preferences, to reveal these preferences via virtual reality aided choice and laboratory experiments for the estimation of total economic value. We also want to develop future scenarios, and we understand that there is a large size of different future scenarios, and trying to document all these different resulting solutions is quite complex. And because of that, we require powerful explainable machine learning methodologies and systems innovation analysis for choosing those on which to build policy recommendations. So in this talk, I'm going to try to introduce you to how we approach the problem of decision-making under deep uncertainty. Deep uncertainty is something that is very relevant for climate change, but also other possible extreme events and non-linearities of our development. Even since 2007, the IPCC report has recognized that objective probabilities are difficult to estimate for many things that have to do with climate change, because it impacts public goods, health, biodiversity, future generations. So at the moment, the literature on how to account for ambiguity in total economic value is growing, but there is no agreed standard. And our literature review pointed to alternative decision-making rules away from expected utility maximization rule. However, instead of finding ideas to refine the theoretical underpinnings, our models and valuation methods, we ended up criticizing this literature. We ended up saying that maybe we don't need alternative decision-making rules. Maybe we need to revisit the way we take decisions under uncertainty and use counterfactual thinking in order to correct time inconsistency in this decision making. So this is a paper about ambiguity aversion, modern Bayesianists and small worlds. Our main result is that ambiguity aversion, the major paradox in decision making under deep uncertainty, when we don't know the probability of different uncertain events. We claim that ambiguity aversion under modern Bayesianism collapses to dynamic inconsistency of beliefs. Ambiguity aversion is a concept that basically means that people show aversion to unknown probabilities. It derives from mathematical economics and decision theory under subjective uncertainty. Modern Bayesianism derives from Bayesian epistemology and Bayesian confirmation theory, and I'm going to explain what that is. And then another big element in our work is the framework of small words. Small words are words where a small number of propositions are required to cover all cases of interest, as opposed to large words where you need a very big number of propositions to cover all cases of interest. And this is where our solution to the ambiguity aversion paradox does not apply. It's a much bigger challenge to dissolve the ambiguity aversion paradox in a large word, if possible. So we also claim in this paper that in small words, modern Bayesianism, apart from normatively appealing, is descriptively possible as well. So let me go back to the basics and refer to Leonard Savage's work on the foundations of statistics, which achieve a simultaneous axiomatization of subjective probability and expected utility maximization, and allow us to think of an agent that does not need exogenous subjective probabilities. All that she needs is in her own mind. So basically, Savage representation theorem provides a separation between tastes and beliefs, and subjective tastes are represented by utilities, subjective beliefs are represented by probabilities, and you can have expected utility maximization rule by combining the two. Now, savage axioms are deviated from in documented paradoxes, which are known as Ellsberg's paradox. Ellsberg is the name of this person that identified this paradox, and the question is whether economic agents behave according to savage axioms or they behave according to Ellsberg. That is, Ellsberg claims that he finds repeatedly evidence against subjective expected utility behavior where people are not probabilistically sophisticated. The key point of Ellsberg paradox is that there are two kinds of events for the agent, the ambiguous event and the unambiguous events, and the agents prefer to bet on unambiguous rather than ambiguous events, and this is consistent with inconsistent with probabilistic sophisticator. So let me go back to the very basic initial representation of this paradox. If you have an urn with 90 balls, you have 30 balls with which are red, and you also have 60 balls that are either black or yellow, but you don't know the number of black or the number of yellow. And then you have your states of nature, red, black, and yellow. And you have 4 arcs, and you have monetary outcomes. And if you prefer F1 or F2, so the basic question is, do you prefer F1 over F2? Do you prefer F3 over F4? And most people prefer F1 over F2 and F4 over F3. So people prefer to bet on outcomes that they know the probability of. They avoid betting on unknown probabilities. So what is wrong with this? What is wrong with this is that if you do the maths, then you can show that this aversion to unknown probabilities does not allow you to be probabilistically sophisticated. And the paradox is very easily illustrated through this very simple line of reasoning. So if you have preferences which basically prefer F1 over F2 and F4 over F3, then you cannot represent these preferences by a subjective expected utility preference function. And if you go into the simple, let's say, comparative maths of this, basically preferring F1 over F2 means that the subjective expected utility of F1 is bigger than the subjective expected utility of F2. And going through the calculations, it gives you a result that says that the possibility of red is bigger than the possibility of black. But if you also prefer F4 over F3, this, and going through the calculations, it gives you that the probability of black is bigger than the probability of red, which is definitely a contradiction. So you don't have subjective, you don't have proper subjective probabilities. And this violation of the subjective expected utility rule is very serious for economics, because it either translates into irrationality or it translates into admitting that savage axioms are too demanding for rationality, and you can decide to change how you represent beliefs in order to avoid the result of non-uniqueness and non-additivity of preferences. So when you have Ellsberg type behavior, you end up with non-uniqueness and non-additivity in your preferences. So the literature has tried to produce new axiomatization, replacing the subjective expressive utility axioms, and tries to come up with non-additive probabilities or multiple probabilities and maximum expected utility criteria in order to devise a decision rules that one can use under decision making with deep uncertainty. However, we've looked closer to this problem, and the real issue is that the source of ambiguity at the moment of the formation of the beliefs, the prior beliefs, the decision maker is faced with asymmetric information about objective probabilities. So the decision maker has specific information for some events and does not have specific information, only background information for some other events. And I mean, background information are basically general characteristics of the chance setup of the hypothesis, the evidence relevant to hypothesis, the entailments, relationships between hypothesis and evidence, whereas specific information are actual outcomes or information on objective chances. And these are the information that you need to utilize in a very specific way in order. This is the specific information is what you need to utilize in order to update your beliefs. So the question is, should we allow specific information to affect the formation of prior beliefs, or should we allow only background information to affect the formation of background beliefs? And let me explain to you explicitly what I'm on about. So your appointee, this is the point at which the decision maker is constructing her priors, allowing for both types of information to affect the construction. So this prior will be used as the vehicle with which the decision maker updates her beliefs by conditionalizing on new evidence. And from this time on, the agent becomes a classical Bayesianist. So when an event occurs at t+1, the decision maker wants to form his new posterior probability of the event A in the light of the new evidence received at t+1. And this posterior is constructed as using the prior, which uses both background information and specific information, and conditionalizes on the new event that occurs at t+1. So this is how a classical Bayesianist works. Now let's see what the modern Bayesianist does. He's again at point t. At point t, he has both background and specific information. However, he does not forget that at point 0, he formed a prior using only background information. So this prior is the prior that will be used as the vehicle to update his beliefs by conditionalization on new evidence, including specific information. So when the DM wants to form her new posterior probability of event A in the light of evidence E, which happens at t+1, then he uses the initial prior which has been formed at the start of his epistemic life, t equals 0, and he conditionalizes event A on both specific information and the new evidence. So what is different with modern Bayesianists is that the modern Bayesian agent requires counterfactual probabilistic reasoning. Throughout his epistemic life, the decision maker will always construct his prior, which has been formed at the start of his epistemic life. And in this way, you avoid time inconsistency. Not only you avoid time inconsistency, but you also resolve the ambiguity aversion. Ambiguity aversion dissolves to just a time inconsistency problem, and it can be solved through educating people in counterfactual thinking. Not only this, but there are additional good normative reasons for being modern than classical Bayesianists. First of all, modern Bayesianists avoids cognitive dissonance, the psychological finding that agents treat hypothetical and actual evidence differently. So, for example, if I am asked to give the probability of surviving an illness of aggressive cancer, I give a higher probability when I know I have this kind of cancer than before I knew that I have this cancer. So if they ask me before I have the cancer, I give a higher probability of death. And if I get the same question while I have this cancer, I give a lower probability of death. So this is cognitive dissonance, and it's basically dissolved through modern Bayesianism. Moreover, modern Bayesianism fits better with Bayesian confirmation theory. It avoids central contradictions arising from the principal principle, which is one of the pillars of rationality, and basically captures the intuitive idea that if an agent X comes to know with certainty the objective probability of an event, then subjective probability of this event must be set equal to the objective probability. Then modern Bayesianism also handles better the problem of old evidence. This refers to scientists commonly arguing for their theory from evidence known long before the theories were introduced. So, for example, the argument that Einstein gave in 1915 for his gravitational field equation was that they explained the anomalous advance of the perihelion of Mercury, which was established more than 50 years earlier. So old evidence can in fact confirm a new theory, and this is handled very well with modern Bayesianism, and also modern Bayesianism ensures faster convergence of options than classical Bayesianism. And of course, it helps to dissolve the problem of ambiguity aversion. And in closing, I would like to say that only in small words our result is relevant. These are words in which you can always look before you leave. It is possible, these are words where it is possible to consider everything that might be relevant to the decisions you make. So a small world is a set of propositions whose number of elements is small, and in small world, a Bayesian can assign probabilities to all the propositions of interest. Apart from small worlds, the world must be non-evolving, and actually this is how Savage framework is constructed. It's an essentially static framework in the sense that it does not allow for the so-called concept formation. It does not allow for formation of new hypotheses or new ideas that are coming into the future. A third option that relaxes classical Bayesianism is the evolving probability model, where you change your probability in the light of new evidence, and you can change it any way you want as long as you respect coherence of probability calculus. So our conclusion, modern Bayesianists dissolve the problem of ambiguity aversion, and the modern Bayesianist ambiguity aversion collapses to dynamic inconsistency. This is non-negotiable irrationality. The modern Bayesianist assumes that informing his subjective priors, the agent makes use of background information only, and specific information, that is information about chances, is allowed to affect beliefs only through conditionalizations. And you conditionalize on the pre-existing prior that was formed at the start of your epistemic life. Bayesianism is, in general, is possible only in small worlds. And as I said before, a third option is the evolving probability model. So this is our basic new idea that counterfactual thinking can correct for ambiguity aversion. And what we are now working on is constructing lab experiments in order to educate people in counterfactual reasoning, focusing on applications that have to do with water systems and extreme uncertainty, and mostly related to climate change, extreme weather events, and see whether education in counterfactual reasoning will give us behavior that is consistent with the axioms of subjective expected utility, or whether people cannot be educated in counterfactual thinking. Counterfactual thinking is something that we are not able to use in every life decision making, or even scientific decision making. So our understanding of people's behavior has in some way to integrate this aversion towards unknown probabilities. I want to close this lecture, if I have a few minutes, by going back to the overview picture of our work, and say that we work on a really interdisciplinary basis, and trying to identify problems, construct the vision, the long-run vision to solving a problem. So agreeing in a very co-designed framework, what is the status quo, what is our future vision, and how to construct the pathways that allow us to reach this future vision. We try to understand the supply side by biophysical modeling and production analysis, and use of cutting-edge technologies. And at the same time, we try to understand the demand side. We try to understand preferences and behaviors, and engage stakeholders in this understanding, and then try to bring together supply and demand over space and time into systemic solutions that will allow us a representation of how we want our different systems to work together in the future, and how we can use technology, but also understanding of human behavior in order to create an optimal interaction between the economy, the society, and nature, that will allow us to go to a steady state, that is a steady state, to allow us to go at a sustainable future, will allow us to embark on a pathway that it will allow us to reach at some point a sustainable interaction between the economy, the society, and the and nature. So we work in 4 major areas. Each slide is a different project with its own budget and a multi-university consortium across Europe and beyond. First, we work on climate change mitigation and adaptation pathways in green and digital solution pathways. We work on sustainable blue growth with many projects on energy production from the sea, demonstrations for co-designing sustainable solution pathways, marine protected areas management, stakeholder engagement in coastal areas and hedging against extreme weather risk. And we also, like I said before, have an accelerator of innovations that are relevant for managing the transition to sustainable seas and oceans. And we also have a big initiative on sustainable Euro-Asian seas, trying to devise sustainable solution pathways for the Mediterranean, the Caspian Sea, the Black Sea, and the Aral Sea. Our 4th area of focus is water, food, energy nexus, smart agriculture, and smart urban water systems. And the project that we just started working on and I've presented to you is, of course, under the smart urban water systems section. We also, like I already said, work on deep demonstrations, research commercialization, and innovation acceleration. And this is mostly our work under the European Institute of Technology and Innovation. And we accelerate startups, we provide programs for professionals in sustainability. We run climathons, hackathons for the climate, and we work very closely with many European funds to further increase the chances of our startup to acquire the sufficient funding to really go towards financial sustainability. As I said, we have 2 big accelerators, the Maritime Accelerator with 25 different innovation companies, 3 of which have secured very big funding last year, and they focus on different aspects from logistics to decision management systems to actual development of alternative fuels, new materials, and so on. And as I told you before, we also work, we have this other accelerator, again, European, on innovations that have to do with climate adaptation. And here we have 120 innovations. With regards to my work on SDSN Europe, we have 4 major initiatives. So one on sustainable agri-food systems and land use, one on the SEES initiative that I introduced before, the European Sustainable Development Report that measures the implementation of SDGs in each European country every year, and also another report that I also lead with Jeff Sachs on the European Green Deal, which basically designs transformations needed for the joint implementation of Agenda 2030 and the European Green Deal. This is the picture of Europe with regards to SDG implementation. You can see that the eastern-south part is less well positioned for meeting the SDG. And I'm closing by briefly referring to the Global Climate Hub of SDSN that will be launched next Wednesday. And it will have its headquarters in Athens. And the mission of this Global Climate Hub is to advise governments for combating the aggravating climate crisis and prevent further deterioration. So we will use all data knowledge and technologies that are available in various fields to develop country-specific action plans to be adopted and reinforced by society. I will stop here. This climate hub has already many global projects, and we want to build on them in order to advise governments, because governments at the moment, they realize the challenges, but they don't have enough capacity, even in the most developed governments, to really identify pathways towards the transition to sustainability. And they need information, and they need guidance now, and capacity building now. And we thought that this would be a good service to provide. Thank you very much for your patience.